In this video, we're going to be discussing logarithmic differentiation of exponential functions. We will see the techniques of differentiating an exponential function here. The basic techniques of differentiating any exponential functions you are given, like y equal to e to the power of u, is differentiating u. Whatever you are given as the part of your exponential function, take that to be u. So you differentiate u, and then you multiply it by the exponential function itself, which is e to the power of u. So that will basically give you your answer. So the y, the x here is going to be e raised to the power of u multiplied by u complement. So when you see u complement in my computation there, it means the differential value of u. So let's get to see few examples I have here. If y equal to e to the power of 5x, how do we differentiate y with respect to x? And then the first thing we do is to recognize what u stands for. In this case, u is always the power of your exponential functions, and the power of our exponential functions there is 5x. So in this case, our u is equal to 5x. And then how do we differentiate 5x? I'll basically recommend one of my videos I put in my YouTube channels. I titled Differentiation Rules. That basically teaches how to differentiate linear expressions or polynomial expressions like we have as a value of our u, which is 5x. So how do we differentiate 5x? 5x in this case, the differential value is going to be 5. It's basically 5 times x raised to the power of 1 minus 1, which is going to give us 5 times x raised to the power of 0. And one of the laws of indices says whatever is raised to the power of 0 is equal to 1. So we basically have 5 times 1, which is equal to 5. So that's how we obtain the differential value of 5x to be 5. So the u complement we have there is 5. And then we bring in our techniques. Don't forget, on the right hand side of the screen there, okay, the technique says if y equal to e to the power of u, so differentiating y with respect to x says e raised to the power of u multiplied by u complement. So we bring that techniques to solving this question, and then what we get to have is the y the x equal to e to the power of 5x, which is standing as your exponential function from the question, multiplied by the differential value of u, which is 5. And of course, if you multiply this by the exponential function, we do have 5e raised to the power of 5x. Let's take a look at another example. If y equal to e raised to the power of 3 minus 7x, like I said, the first thing you do is to recognize your u, and u is always the power. You make use of u as to stand for the power of your exponential function. So in this case, our u is going to be 3 minus 7x, and then we differentiate u. How do we differentiate u, which is 3 minus 7x? Like I said, just go basically and watch my video that I put together, and I titled Differentiation Rules. That's going to teach you better how to differentiate simple question like this. So differentiating u in this case is going to give us minus 7. And how do I obtain that? Of course, we differentiate 3, which is a constant term. Differentiation of a constant term is always 0. And then we differentiate minus 7x. So differentiating minus 7x is going to give us minus 7 multiplied by x raised to the power of 1 minus 1. And that's going to give us minus 7 times x raised to the power 0. And eventually we have minus 7 times 1, because whatever is raised to the power of 0 is 1. So basically we have the differential value of u to be minus 7. And then we bring in our techniques. Our technique stands and it works for whatever exponential functions you want to differentiate. So the technique is e to the power of u, as we can see on the screen, multiplied by the differential value of u itself. So when you bring that techniques to solve this question, and then we basically have the y the x equal to e raised to the power of 5x multiplied by minus 7. And then when we multiply these two together, okay, we can just compute it for a better presentation. Okay, so we have minus 7 multiplied by e raised to the power of 3 minus 7x. So that is the answer to such a question we have there. Let's take a look at another example. Then if you have y equal to e to the power of x, how do we differentiate y so that we have a correct answer? We still bring in the same techniques to differentiating exponential functions. Okay, so we recognize our u, which is going to be x, and then differentiating x is going to be 1. That is x raised to the power of 1 minus 1, and that's going to give us x raised to the power of 0, and whatever is raised to the power of 0 is equal to 1. That's one of the laws of indices there. So the differential value of x is 1, so we record that as u complement, which is 1, and then we bring in our techniques. Okay, so differentiating y with respect to x now is equal to e raised to the power of x times 1, and then that leads us to our final answer. For a better computation of the answer, we have 1 times e raised to the power x equal to e raised to the power of x. Okay, so this is a very unique kind of question. Anytime you differentiate e to the power of x, it stays the same. It's equal to e raised to the power of x. But if you need to show your steps, that's what you have on the screen there. Let's take a look at another example. If you are given y equal to 4e raised to the power of minus x, this is a kind of unique question in the sense that this one carries, our exponential function carries a coefficient of 4. So what we basically need to do is to concentrate on the exponential part. So we don't need to necessarily differentiate a constant term which is the coefficient of 4 there. Okay, but eventually it will get involved when we want to compute our answer. So let's concentrate on the exponential part of the question, and then we'll bring in our techniques of e to the power of u multiplied by the differential value of u. Okay, so that means we recognize our u to be minus x, the power of your exponential function. So if u equal to negative x, then our u complement is going to be minus 1. Okay, if you differentiate minus x, you're going to get minus 1. And then the y dx in this case is going to be 4, which is the coefficient from the question in a bracket. Then we bring in our techniques of e raised to the power of u multiplied by u complement. So in this case, our e raised to the power of u is e raised to the power of minus x multiplied by u complement is going to be minus 1. So we can just multiply all the terms we have there together, and that leads us to 4 in a bracket minus e raised to the power of minus x. We can simply leave our answer this way, but just to have a better presentation of our answer, and then we can leave it as minus 4e raised to the power of minus x. Let's take a look at another example. If y equal to 9e raised to the power of x cubed minus 7. This looks like the previous question we just solved, in the sense that this question carries a coefficient of 9. So like I said, we do not necessarily need to differentiate the constant term of 9 there. All right, so we just concentrate on the exponential part of the question, which is e raised to the power of x cubed minus 7. So we recognize our u in this case to be x cubed minus 7x. Then how do we differentiate x cubed minus 7x? Of course, it has to be 3 multiplied by x raised to the power of 3 minus 1 minus 7 times x raised to the power of 1 minus 1. And then eventually we have the differential value of u to be 3x squared minus 7. Like I said, if you really want to learn how to differentiate the basic linear expressions or polynomial expressions like we have as the value of our u, I recommend one of my video in my YouTube channels that I titled Differentiation Rules. That's going to teach you better on how to differentiate linear expressions like this. So we have the differential value of u to be 3x squared minus 7, and in that case the y dx is going to be, don't forget your coefficient of 9 is going to be involved in the computation of your answer. So it's going to be 9 in the bracket e raised to the power of x cubed minus 7x, that's e to the power of u. I'm bringing in out techniques now. Then multiply by the differential value of u, which is 3x squared minus 7. So by the time you multiply all this term together, okay, for a better presentation of our answer, we can just, that's basically the answer, but we can have a better presentation of 9 in the bracket 3x squared minus 7 in the bracket e raised to the power of x cubed minus 7x. That is the answer to such a question. Thanks for watching. Kindly subscribe to my YouTube channels.